All right, so this will be yet another part of the workshop where you learn how to interact with your smartphone and the microscope. So this is something we built previously. So this is, I'm just disconnecting or just leave it like that. So here you have the camera, you have one folding mirror so that you can create an image from your sample with the finite corrected objective lens. And what we are trying to do now is replacing this camera by your cell phone. And so for this we would need to have an eyepiece. So this here is just an arbitrary eyepiece with a 10x magnification. And so the way it works is it assumes that you have the intermediate image somewhere here. So it depends a bit on the architecture of your eyepiece, whether it's inside or outside. And so usually, yeah. And then this is designed for your eye so that you can conveniently look at something that's in a distance of 25 centimeters or 250 millimeters. And so the good thing is that our eye or the cell phone lens, they behave pretty much the same. So if you now just take this lens and put it closer to the cell phone lens, you see that at one point there's the black aperture. So when those two apertures, the one from the cell phone, the entrance pupil and the exit pupil from the eyepiece match, then it's a correct image geometry. And you even see that there's a ruler inside the eyepiece. So what we're going to do now is replacing this camera by 2 or 3 more cubes so that we can have a folding mirror and also the plate for the smartphone. So what we're going to do now is just getting rid of the camera here. We need this cube so that there is still some space because the cell phone cannot be in the place of the Z stage, obviously. So we just keep this base here empty. We have to extend it, so we just add one more base plate right here. And then we are going to assemble the mirror. So this one again, almost close it, and then before you close it entirely, add the mirror. Oops, not lucky. So, nope, not lucky at all today. Then let's just do it properly. Well, there's always room for improvements. So, there we go. This goes here so that the beam is folded like that. And yes, the distance is now way longer than the tube length, but we are just dealing with that for now. That's fine, meaning that just the magnification is increasing. And so the next bit will be having yet another cube that is holding the eyepiece here. So the eyepiece has to point downwards. And then we just assume that this object is now imaged here so that we can have the eyepiece re-imaging this intermediate image almost to infinity so that the cell phone then can capture it. So the whole setup will look like that. And the last piece would be the smartphone holder. And for the smartphone, we just have a plate that can adapt to the cube on the top here. So that you just mount that on the top. To make everything a little bit more robust, we will also have the second pile of cubes right here, so that you can just add this here on top, and then have yet another set of cubes here just to make it a bit more robust. It's not necessary, but then it feels actually more like a microscope. So light goes through, it's reflected here, and then also re-imaged by the eyepiece right here. So one thing we can also think about is eventually turning this into a finite infinity corrected microscope. So for this, you can take, for example, a tube lens, which is in this case just a Thorlabs Achromat. So assuming this lens here is producing an infinity corrected beam right here, so this is then infinity space, you then image the infinity space with another lens, in this case it's 100 millimeters, in the front focal plane, so to say, from the eyepiece. So the lens itself has to be optimized for either finite corrected or infinity corrected optical systems, but to just show the effect, you can also play with that so that you insert the lens right here so that everything that's in the focal plane is propagated to infinity, then focused 100 millimeters far away, so that's like 50 and 100, and then this eyepiece is just reimaging that into the plane of the cell phone. For the illumination, we choose something that's a bit more coherent, so we just take, for example, those LEDs that are in the center. So I just switch on, let's say 2, and then I'm now going over and put this here upright, and also the next step will definitely be placing the cell phone right here, and also shading the blinds. So you can observe the process how to mount that. So maybe I'm lucky to have it working the right way. So what you see here is like if you approach the eyepiece, there's this bright spot, that's the zeros order, or like the stuff you want to see at maximum sharp. So my cell phone is very slippery, so I'll just put a case around it to make it sticky to the base plate. So I'm just using that. So if your cell phone is too sticky, I think that's just normal. So what you see now is this bright spot. So eventually you see already some sample if you move it up and down, but it's not perfectly aligned yet. So there's the red blood cells we have seen earlier. I just tune it manually a bit so that you may see some contrast. So there's the edge. You can also do that through ImSwitch and the motor, of course. There are some blood cells. I think we're already out of focus again. And so it's not the perfect image yet. So we are going to tune that. So by changing the distance between the eyepiece and the camera plane, you will be able to get the apertures matching. So therefore we just need to move the eyepiece closer to the cell phone. Oops, that was a bit fast. But then you see that now the exit pupil is matching the entrance pupil of the cell phone, and you have a very nice black rim around the cell phone. And then if you play with the illumination, for example, you can even get some sort of dark field. Let's try that. So now you have a black background and the red blood cells. And I'm trying to focus the sample a bit better. And for this, I'm tuning 10 steps in the ImSwitch, and I'm going up or down, let's see. So the contrast gets better. Yeah, and you already see that at the edges of the field of view, the contrast goes down. That's just due to the wrong optics configuration we use here. So I'm just going to a different place. And you see already, I'm just focusing a bit better. This is now a 10x objective lens in dark field. So let's go back to bright field. So I'm just turning on this one center LED, and you can identify individual blood cells. I think that's nice. Let's also swap the sample to see something else. So this here now is German Maiglöckchen. Just fixing it. And so what you eventually see now, there's like the black rim on one edge. So this is just because the cell phone was slightly moving. So we have some fun effect here. So always make sure that the illumination is distributed properly. And now we again can refocus. And yeah, that's basically it. So you can just easily use whatever lens you have, whatever cell phone you have with an eyepiece and integrate that in your microscope. That's the whole thing. Yeah, thank you.